Well, hello. Let's change this view a little bit. We're going to focus on other objects in the solar system today. And you've been doing a project related to that. And part of the deal is just to kind of familiarize yourself with the fact that there are things that are not planets that are out there, that some of them are actually more interesting than planets. So we'll kind of talk about those a little bit in terms of what is out there. And I think you, after your project, you probably have a pretty good idea about moons and dwarf planets and planets. Moons are going to orbit the planets, or the dwarf planets are what they call natural satellites. And a dwarf planet doesn't quite meet the criteria of a planet. It's a little small. But one thing about moons, dwarf planets, and planets is that most of them are spherical. Okay? If they're not spherical, there's a reason why, and we're going to talk about that. So what an asteroid is, it's usually a rocky or metallic non-spherical object. And it's usually going to be found in between Mars and Jupiter. That's usually where they are. But if you look at this, it kind of looks like a lumpy baked potato. It's obviously been impacted by lots of craters. It's seen some mileage along the way. But there's several reasons for this. One is that there's going to be several collisions. It doesn't have an atmosphere, so things aren't going to burn up in the atmosphere. But secondly, it's not going to be spherical, because in order for an object to be spherical, it needs to have the mass large enough where the gravitational pull is going to be strong enough to kind of flatten stuff out. An asteroid simply isn't going to be big enough to do that. Okay, so things like asteroids and comets aren't going to be spherical the way that planets and dwarf planets and most moons are. Okay, and that's because the gravity simply isn't strong enough, because it's not big enough for that to happen. So how many asteroids are there out there? We know we've got 8 planets and 200 some moons and stuff. But if we look at asteroids, this is almost countless. Okay, so if you have more than a kilometer, you've got a couple million. You've got something larger than 100 meters, which would be about the size of Barn Bluff if you really want to talk about it. There's more than 150 million of those. And then if you got something that's roughly the size of a classroom, it's an unbelievable amount that is out there. So these are not uncommon objects. But as we mentioned, they're usually found in between the orbits of Mars and Jupiter, but there's some that are kind of locked in Jupiter's orbit. So if this is the Sun, and this is Mercury, and this is Venus, Earth, and Mars, and then you have Jupiter out here, so the Earth is 1 AU, Jupiter is about 5 astronomical units, is about 5 times the distance the Earth is from the Sun. Most of these asteroids are found in this area around the Sun, in between the orbits of Mars and Jupiter. But there are some that actually follow in Jupiter's orbit. They just kind of lead ahead of it or kind of trail behind it. It's kind of odd, but the reason why is because they're gravitationally locked with Jupiter and the Sun. So it kind of forms a neat little kind of equilibrium point between these two, where they have an equal amount of gravitational pull. So that's where asteroids are. And asteroids, actually, if you could mine the material in an asteroid, would be quite valuable if you could harvest what's in there, because the metals that are in there would be of quite some value. Let's contrast an asteroid with a comet. You notice that the comet looks very different here. It's glowing brightly, but it only glows brightly at some points in its orbit. Okay? Basically, a comet is a dirty snowball, if you really want to not be too technical about it. Okay, they have very, very elliptical orbits. Remember, orbits of most planets aren't quite circular. That's why the Earth isn't always the same distance from the Sun. But comets are extremely elliptical, but they're going to glow as they approach the Sun, because the solar radiation is going to blast material off the surface and kind of vaporize a lot of the material of the comet. So if a comet makes several passes at the Sun, it's eventually going to disappear. Now, this is the only comet I've really witnessed in my lifetime, and it's a very, it was actually a stunning sight. It looks unlike anything else in the sky, and you'll definitely know it when you see a comet, because it's going to look like a big smear in the sky, and each night it's going to get a little bit closer to the Sun. So it's going to come around here, it's going to go around the Sun, and then come back the other way. This was kind of Comet Hale-Bopp, and this happened in about the mid-90s, but it was a stunning sight night after night in the spring of that year. Now, what a comet is, here's this very elliptical orbit, but you're also going to see that Out here, no one really knows. I mean, the comet's just out here in the depths of space. But as it approaches the sun, it's going to speed up because the gravitational pull of the sun is going to get stronger as you get closer. Remember, gravity is dependent upon distance. But then the solar radiation from the sun is going to blast material off this, so the tail of this comet actually always points away from the sun. Even when it's traveling away from the sun, the tail of the sun precedes it. It's kind of like a dog with flappy ears, and the flappy ears are going to flap behind it when it's going into the wind. But here, that tail is going to actually precede it. So you're going to actually see a comet usually twice, both as it's approaching and as it's leaving. Now, these comets are very small. Okay, they're not that big of objects, and they eventually will vaporize and disappear. But sometimes their orbits take thousands of years. Others have orbits which are about 3 years. Okay, it kind of really depends upon how big this elliptical orbit is. Okay, so one thing that comets can produce are what are called meteors. And the reason why meteors are produced, and I'd ask that you look at the first link there. There are meteor showers throughout the year, and meteors are oftentimes misnamed as shooting stars. They're not stars at all. They're really just basically fragments of debris that run into the Earth's atmosphere and burn up because they're traveling at several thousand miles an hour, and the heat is going to basically vaporize them, and it creates this intense trail. And these meteors, the debris from these meteors is oftentimes only going to be about the size of a sand grain or maybe the size of a frozen pea. Very, very small. And what happens, the reason why these meteor showers are created, you can always count on them, let's say in August and December, and they call them certain names like the Perseid meteor shower or the Taurid meteor shower. And that's because at certain times in the year, Earth's orbit passes through the path of a comet. So if this is the path of a comet, it's leaving behind all sorts of breadcrumbs, just like Hansel leaving breadcrumbs behind him on the trail in the woods. This comet is leaving all sorts of debris. It's a really, really messy object. It's leaving lots of debris in its path as it goes around the sun. And when you see a meteor, it's because the Earth is passing through this field of debris, and this material is burning up in the atmosphere. Okay? And that's why you can count on every time of the year that the Earth passes through this point, you can count on there being a meteor shower because we're always going to run into that debris field. So we're going to, sometimes they are called shooting stars, but that's really not a correct application for it. Okay? Now, if the meteor is larger than that, if it gets big enough where it can pass through the Earth's atmosphere and actually make it to the Earth's surface and be located, then we're going to call it a meteorite. And this fellow in Indiana woke up one morning and found that one had gone through the back end of his rather classy car here. Here you see it sitting in the ground here. And oftentimes they are easy to pick out, specifically in deserts and in icy areas like glaciers, because they're going to look unlike any other rock in the area. They've been scarred. They kind of look almost like marshmallow that's been toasted too long. And if you were to come across one of these in the desert, you'd be an instant millionaire because you'd be able to sell it to a museum. And some people try to make their living doing that. They look for meteors. They are fairly easy to pick out against the background. Most of them are relatively small. This happens to be one of the larger ones. This is this one ended up in Oregon, and it would have been a bad day to be underneath this when it came crashing into Earth. But what I'd ask that you do is there are also a couple links here. This happened a few years ago in Russia, and an object probably about 30 meters across came hurtling towards the Earth's atmosphere, and it didn't quite make it all the way to the ground. There are bits and fragments that did, but it exploded above the ground, and I want you to watch how bright it got, and I want you to watch kind of the reaction after that happened. Okay, so that's kind of an interesting feature there. One event that happened because of a meteor coming close to Earth was what's called the Tunguska event, which happened in Siberia in 1908. And basically these are about 100-foot tall conifer trees that were blasted down like matchsticks over about a 30-mile radius around where this thing landed. So these events do happen, okay? We can't avoid them. There's debris in the universe, in our solar system, that's eventually going to impact Earth. And one of these probably caused the downfall of the dinosaurs. So I just wanted to introduce you to the idea of what the difference was between asteroids and comets and add them to our zoo of creatures that are in our solar system. Okay? So, do what you need to do in terms of the lesson for today, and we will talk to you next class.